Fourth grade into math lesson 14.1, decompose fractions into sums. I can decompose visual fraction models into sums and model the decomposition with addition equations. Spark your learning. Megan, Zoe, Jack, and Gabriel are sharing these pieces of watermelon. Some of the friends like watermelon more than others. Megan wants to eat the most pieces of watermelon. Jack wants to eat the same number of pieces as Gabriel. Zoe wants to eat more pieces than Gabriel. How can you represent the amount of watermelon each person will receive if they eat the rest of the watermelon? So first, who wants to eat the most? Let's list that. Megan, right? Okay. Then Jack wants to eat the same number of pieces as Gabriel. Zoe wants to eat more pieces than Gabriel. So who would be next? Zoe. Okay. And then who would be next? Jack and Gabriel, right? And they want the same amount. Okay. So how many total pieces do we have, guys? Well, as I say, there's technically 8 sections, right? But one section is gone, correct? Okay, so we have a total of 7 pieces. Okay, so how many can we maybe give Megan? 2. Okay, let's try 2. All right, let's make it 2. So if I put M on that, that leaves how many left? 5. Okay, but it also says that Megan wants to eat more than Zoe. So so if we only give Zoe 1, then Jack and Gabriel get none? That wouldn't work, right? Okay, so we can give Megan what? 3. And then how many would Zoe get? 2. So she still has, Megan still has more than Zoe. And then how many would Jack and Gabriel each get? 1. Oh, sorry, I forgot. J and G. Okay, so does that work? Yes. 3, 2, 1, 1. So does that fit? Megan wants to eat the most pieces of watermelon? Yep, she has 3. Zoe wanted, it says Zoe wants to eat more pieces than Gabriel. Does that work? Did she eat more than Gabriel? Yeah. Yep. And then it says Jack wants to eat the same number of pieces as Gabriel. So did Jack eat the same as Gabriel? Yes. Build understanding number 1. Tony and his family visit a state park. They grill 5 6-pound of hamburger for lunch. The hamburger is made into 1 6-pound patty. How many hamburger patties do Tony and his family have? Use a fraction model to represent the amount of hamburger Tony and his family have to grill as patties. The whole represents 1 pound. Okay, so if we did a bar model, how many pieces would we break it into, guys? And of that whole pound, how many are they going to use? So we have 5 6, right? How many are they going to use? 5 of them, right? And then each one of those represents what? 1 6, correct? So how many boxes did we color in? 5. So how many hamburger patties will they get? So 5 patties. Okay, so letter B, what does each unit fraction represent in the problem? A unit fraction tells the part of a whole that each piece represents. The numerator of a unit fraction is always 1. Okay, so what was our unit fraction, guys? 1 6, right? Okay, so it represents 1 6-pound of what? Of hamburger, correct? Or 1 patty. So what addition equation can you write to model the weight of a hamburger or of the hamburger as the sum of the weight of the patties? So how many times did I write 1 6? 5. So 1 6 plus 1 6 plus 1 6 plus 1 6 plus 1 6 equals what, guys? The 5 6, correct? So how many 1 6-pound hamburger patties do Tony and his family have?
5 6.
5 1 6 patties. Actually, 1 6-pound patties. Now, when I wrote that, does anybody know why I put that dash there? So it doesn't look like a mixed number. So it doesn't look like 5 and 1 6 because those hamburger patties would be huge, right? Okay, they take forever to cook. So we want to acknowledge that it is 5 individual 1 6 patties and not just one big lump of 5 and 1 6. Because did we even have 5 and 1 6 pounds? No. Okay, so we are acknowledging that it's 5 individual ones. Number 2, Tony and his family drove 7/12 of the distance across Michigan on Saturday. What are 3 ways they could break up the drive into 2 parts so they could stop and walk their dog? Shade the visual fraction models to show how they could break up the drive. Then model each with an equation. Okay, so the first one we would do, so they said they drove 7/12 of the distance, right? So we would write 7/12 here, and then how many of those do I shade? 7, right? Okay, so how could I break 7 apart into 2 different sections?
You could 1 and 4 in the other.
3 and then 4, right? Okay, so I could do 3/12 and then 4/12. And what did we say when we started? In order to add 2 fractions together, they have to have what? A common denominator. So could I do that? Yes. Okay. So 3 and then 4 here. Okay. Once again, our total is 7/12. So we still start with 7/12. How could I break 7/12 apart? What else can I do?
6 and 1.
I can do 6 and 1. So I could do 6, 12, and I could do 1/12. Okay. And 7/12 again. Okay, how can I break it apart? Can I do 5 and what? 5/12 and 2/12 because 5/12 plus 2/12 equals what? 7/12. Check understanding number 1. Write 4 6 as the sum of unit fractions. So what does a unit fraction have to have in its numerator? What number?
1.
Number 1, right? So I'm going to write 4 6 equals, what am I going to write? 1 6. How many times? 4 times, right? Write the fraction as the sum of 2 fractions. So these 2 and 3 are kind of like number 2 up above, okay? So basically, what is a way I can break 4 apart? So 2/10 plus 2/10. If I would have had another student say 3/10 plus 1/10, would that be wrong? No, okay, because 3 plus 1 is 4, okay? All right. If I had a student say 4/10 plus 0/10, would that be wrong?
Yeah.
Yes. Because is 0/10 a fraction? No, it would just be 0, right? Okay, so yeah, that would be wrong in that case. All right. What about 500? Okay, so maybe 300 plus 200. Okay. What if I would have had a student put 400 plus 100? Would I take it?
Yeah.
Yes, because that would still be the same of getting 500. On your own, number 4, model with mathematics. Carlos buys his carton of eggs. He uses 5 eggs to make breakfast for himself and his sister. Draw a fraction model to show the fraction of the carton of eggs Carlos uses to make breakfast. So we need to draw a bar model. How many pieces do we break it into? How many eggs are in that carton? 12. So we need to break it into 12 pieces. So each one of those pieces is how much?
1.
Is 1/12, right? Okay, then how many eggs does he use? 5. So I'm going to shade in 5 sections. And then they want to know what addition equations can you write to model the fraction of carton of eggs Carlos eats and the fraction his sister eats. So what would we do? So his would be what? So it says that, what would we do? He eats 5/12, right?
No, him and his sister.
Oh, him and his sister. So we could do 5/12, which could be maybe 3/12 plus 2/12. Maybe his sister doesn't eat quite as much as him. Could we do 5/12 equals 1/12 plus 4/12? Okay, so either way, all we need to get is what on the top? 5, right? Okay, so write the fraction as the sum of unit fractions. So what is it going to be for 5? There's only one answer for this one. What is it? 1/3 plus 1/3. You can only break 2 in one way, right? Okay, 3/4. What can I do? 1/4 plus 2/4. Okay. What about 7? 2/5 plus 2/5. Could you have done 1/5 plus 3/5? Yeah, I would take that too. Number 8, model with mathematics. Aaron and 3 friends equally share the rest of the pie shown. What fraction of the whole pie do Aaron and her friends eat? Write an equation to justify your answer. So, how much is left of the pie? 4/6, right? So 4/6. So, how am I going to break that apart for 4 people? Each person would get what? 1/6, right? So you write a unit fraction, 1/6 plus 1/6 plus 1/6 plus 1/6. So each person would get how much of the pie? 1/6 of the pie. Number 9, use structure. Write the fraction 6/8 is the sum of 2 fractions in 3 different ways. So what's one way I could write it? 3/8 plus 3/8. What's another way? 2/8 plus 4/8. Now, can I also write it as 4/8 plus 2/8?
Yes.
Yeah, it can go either way. And then what's one other way? 1/8 plus 5/8.